Hey guys, welcome back. We're going to do the buffer example. And this is the blood problem. Blood is buffered by carbonic acid. So we got carbonic acid and the bicarbonate ion. Normal blood plasma is 0.024 molar. Oh, no, wrong color. Come on, undo. It's not undoing. There we go. Is 0.00024 molar in the bicarbonate and 0.0012 molar for carbonic acid. Gives you the pKa. Gives you the pKa at body temperature is 6.1. 3 questions. What's the pH of blood plasma? Question number 1. Gives you a volume of 5 liters for a normal adult, right, of blood. Question is, what mass of HCl can be neutralized by the buffering system before the pH falls below 7? So the pH below 7 for that one. And then given the volume for part B, what mass of sodium hydroxide can be neutralized before the pH rises above 7.8? All right, so we have 3 questions here. And let's get to it. So we have our weak acid, which is H2CO3 carbonic acid plus water. And then we will have, of course, hydronium. And we will have bicarbonate. All right, so initially we have 0.024 molar, and we have 0.0012 molar. And so we have a buffer. We got a buffer. So if we have a buffer, we can use the Henderson-Hasselbalch equation. To solve this, and that is the pH equals the pKa plus the log concentration at A minus all over HA, right? Well, let's put this out. The pH. Do we know the pH? No, that's what we're looking for. pH. pKa. I'm going to write it one more time. pKa plus the log. And so this might benefit us. We have the concentration of the base and the concentration of the acid. Well, the base is HCO3 minus. The acid is H2CO3. I think we can solve this now. So the pH would equal what? pKa, which was 6.1, plus the log. All right, our base is 0.024 molar, and the acid is 0.0012. So if you calculate that, go ahead. What do you get for the pH? Go ahead and pause it. Calculate the pH. Come back. I got 7.40 for A. Hopefully that's what you got as well. All right. So there's A. A. All right. B. The volume of blood is 5 liters. What mass of HCl? We're adding HCl now, right? Which is strong acid. Which means I'm thinking this is going to go into H plus or H3O plus and Cl minus, which no hydrolysis. So that's fine. So we're going to add our hydronium, our HCl, plus what? Well, that's an acid, so it's going to react with the base. Well, which one's the base? It would be bicarbonate. All right, these are both in solution. All right. And on the other side, we'll hit our weak acid, H2CO3, and water. All right, so now we have our balanced equation. So we're going to start with 0.024 molar and 0.0012 molar, right? That's our initials. We're going to add how much acid that's going to be, whatever concentration we need. So minus x, plus x. 0, we'll have 0.024 minus x, and 0.0012 plus x. We're still in a buffer, right? Because we're assuming, the assumption is that x is between 0 and 0.024, right? So we're assuming that this, well, let's just go down here. This subtraction is not, x is going to be above 0 and below 0.024, right? So that we'll have that subtraction. It can't be above 0.024, because if it's above 0.024, then we no longer have the buffer. So let's plug this into our formula, pH, which the pH was 7.0, right? That's not a big range of pH for our blood if you think about it. 7.0 equals 6.1. All right. What am I doing? I am doing this formula here, right? This formula is coming down right here, okay? Plus the log our acid and our base. Our base is up top, so it's 0.024 minus x and 0.0012 plus x. All right, what do we do first? The subtraction. All right. Bring the 6.1 over, and I get 0.9, right? So we get 0.9 equals the log of 0.024 minus x and 0.0012 plus x. So now we have to do 10 to both sides. 10 to the 0.9 is 7.94 equals 0.024 minus x all over 0.0012 plus x. All right, so now we got to bring that up. Why don't I use red? I'll bring that up. So now we have 7.94 times 0.0012 plus x equals 0.024 minus x. All right, so now we have to do a little bit of algebra. I got 7.94 times 0.0012. I'm getting 0.0095. Oh, not red. 0.0095 plus 7.9 for x equals 0.024 minus x. Rearranging. All right, I'll bring the x over, so I have 8.94x equals 0.014. All right, so for me, x, I get 0.0016. All right, so that's not what we want, though. All right, we have 5 liters of blood. And we just found out that in 1 liter, we have 0.0016 moles of HCl. And then we know that 1 mole of HCl is 36.46 grams of HCl. All right, because that's the molar mass, and I get 0.29. Hopefully you get 0.29, 0.29 grams of HCl. And that's what I get for part B, which is not a lot. 300 milligrams is not a lot of HCl. Right, I know that'd have to be in your veins, but still, not a lot. All right, finally part C. Part C. So I'm going to scroll back up. Given the volume for part B, 5 liters, what mass of sodium hydroxide can be neutralized before the pH rises above 7.8? So we got NaOH, which we don't care about, right? This is strong. Na plus OH minus. No hydrolysis. So we have OH minus. And that's going to react with which one? Well, that's going to react with the acid, H2CO3. And of course, we're going to get our bicarbonate, HCO minus. And we're going to get what? Well, water. So initially, we still have our 0.0012 molar carbonic acid and our 0.024 molar bicarbonate. And we're going to have some base added, however much base. So this is exactly the same, except it's going the other way. So we got to know, the trick with this one is which way is the reaction going? What's reacting with what? What's the acid, what's the base, and how are we reacting? And so we're going to have a minus x, plus x. So we'll have no base. We'll have 0.0012 minus x and 0.024 plus x at equilibrium, where our blood pH is 7.8. All right, so let's plug this in. Oh, not blue. pH equals pKa plus the log concentration of HCO3 minus all over concentration H2CO3. So 7.8. I'll use the colors again. 7.8 equals 6.1, right? Yep, 6.1. No, I use purple for that. Plus the log. Our base, 0.024 plus x. Oh, I used blue for the x this time. And 0.0012 minus x. All right, first thing again, we got to get the log by itself. So 7.8 minus the 6.1, which would be 1.7. So we have 1.7 equals the log. We got 0.024 plus x and 0.0012 minus x. All right. Now, 10 to both sides. And 10 to the 1.7, I got 50.12. equals 0.024 plus x all over 0.0012 minus x. All right, so now we got to take this bottom and bring it up. So we have 50.12 times our 0.0012 minus x equals 0.024 plus x. All right, now we got to multiply. We got to distribute the 50.12. So I get 0.060 is what I get here. Minus our 50.12x equals 0.024 plus x. All right, like terms, we get, hopefully we get 0.3036 equals 51.12x. Divide both sides by 51.12. X would equal, I got 7.04 times 10 to the negative 4. Which equals the concentration of hydroxide, which equals the concentration of sodium hydroxide in this case. All right, so now we got to figure out the grams. So we got the concentration of hydroxide needed for this human's blood pH to be 7.8. But we're going to have to start with our 5 liters again. And our concentration of 7.04 times 10 to the negative 4 moles of sodium hydroxide per 1 liter. And then we know that 1 mole of sodium hydroxide is 40 grams. Right? And the reason we know that is sodium's 22.99, hydrogen's 1.01, and oxygen's 16. And if we get this, I got, hopefully you get 0.14 grams. That's what I got for C. All right. So that's a blood one. That's a good one because it talks about what the buffer's pH is and then what happens when you add acid or you add base and how to calculate that pH where you're still in what we call the buffer region or buffer zone or whatever you want to call it. All right. Hopefully that works for you guys. If you have any questions, feel free to reach out. Otherwise, I'll see you in the next one. Take care.